Hi everyone. So in this lecture we're going to talk about fractions, and if a and b are real numbers, then the expression that we would write for a fraction of a over b, we would write it like this. And the only requirement that we have is that b is non-zero. Now this could, a and b could be any real numbers, but remember before when we were talking about rational numbers, in that situation you would want a and b to both be integers. Okay, but in general, a fraction, you can have a and b be any real numbers as long as b is not zero. We don't want to have zero in the denominator. You don't want to divide by zero. Right? That's not allowed. But some terminology that we have, the numerator is the top part. That's a, right? That's the top part of the fraction. And then the denominator is b, the lower part, the bottom part of the fraction. One thing that we need to know is what are equivalent fractions. So equivalent fractions have the same value on the real number line. So let's just write out thirds, for example. Okay, so let's say 0 is here, all right, and let's just mark out thirds here. So over here we'll have 1. Okay, but third of the way, a third of the way to 1 would be about here, right? And then 2/3 would be here, and then 3/3 would be the same thing as 1. So here's one example where you can actually see that we're kind of thinking of 1 in another way. We're representing it as this fraction. Okay, but to make this a little bit more clear, let's look at sixths. So let's start at 0 again, and we'll mark 1 over here. But now let's go a sixth of the way to 1. So we would actually be here, 1/6. And then if we went 2/6 of the way, here we see that we're actually at the same distance as 1/3. So we're at the same value on the real number line, right? Because we're kind of measuring that distance there. And so on. So we'd have 3/6, which would actually be the same as a half. It's a halfway between 0 and 1, right? So you can simplify this thing or reduce it if we needed to. But just note right now we're saying that two fractions can actually be the same. They have the same value, but they have different representations essentially. Okay, 4/6 would be next, and then 5/6, and then finally 6/6, 6/6 would be the same as 1. Okay, so can we write out this kind of, what are the properties that we're getting at here when we're talking about equivalent fractions? Right. So one property that we can utilize is if you multiply the numerator and denominator by the same number, it never actually changes the value of the fraction. So before I write out that property, notice if I have 1/3 here, I can multiply the numerator and denominator by 2, and then I'd get 2/6, and that'll actually give me the same fraction. So that's what I'm talking about with this first property. So first property, if multiplying numerator and denominator by the same number never changes the value of the fraction. Okay. The only thing you have to be a little bit picky about here is this number. You're not allowed to use 0. Okay, because you never want to have a 0 in the denominator. Okay, but any other number that you want, you could multiply your fraction by. So in this case, if you multiplied the numerator and denominator by 2, you'd get 2/6. Over here, if I took 2/3 and I multiplied the top by 2 and the bottom by 2, I'd get 4/6. Right, so these two would be the same fractions. Okay, second property, you could do the same thing but divide. So dividing the numerator, dividing the numerator and denominator by the same number also never changes the value of the fraction. Okay, so, and same thing goes with this. One little picky thing we just want to be aware of, you can't do that with 0. But these two properties here are very nice because they kind of are going to be a quick way that we can check whether or not two fractions are actually the same fraction, or maybe there's a way that we can take a fraction and reduce it into the simplest possible way that we can, and then it's easier to kind of do comparisons and arithmetic and algebra in general. So let's start with an example. Let's try to write 3/4 as an equivalent fraction. We'll try to come up with a new fraction that's equivalent to 3/4, but it'll have a denominator of 20. So if I have 3/4, okay, if I want a denominator of 20, then I'm going to make the denominator bigger. So if I try to use this property 1 here, that I can multiply the numerator and denominator by any number that I want, I'll have an equivalent fraction. So one thing you could do is I could multiply the bottom by 5, and that'll give me 20 in the bottom, right? But in order to have an equivalent fraction, I got to make sure that I also multiply the top by that same number. So if I do 3 times 5, then I'll have 15. Okay, so here is an equivalent fraction to 3/4, but I'll have a 20 in the denominator. Okay, and we could try to do the same thing with another fraction. So let's say that we start with 18/24. Can you write that as an equivalent fraction, but with a denominator of 12 instead? So if I start with 18/24, if I want to end up with a denominator of 12, well, it looks like I'm making the denominator smaller, and I can do that by division. I could divide the denominator by 2, and I will get to 12. So if I just do the same thing to the top, I'll divide that by 2, then I should end up with an equivalent fraction, and I do. One other fraction we want to be familiar with is the reciprocal of a number. So two numbers whose product is 1, those are called reciprocals of each other. Okay, so let's give the reciprocal of each of the following numbers. So the reciprocal of 4, well, we'll just do 1/4. Okay, and you can check, 4 times 1/4, this would give you 1, because that's going to be the same thing. Like if you wanted to check this, right, 4 times 1/4, this is the same as 4/4, which is 1. Okay. The reciprocal, the quick way to just think of a reciprocal is you're just doing 1 over the number. Okay, so the reciprocal, if you happen to have a fraction, is just flip it. Okay, so the reciprocal of negative 1/2, this would just be negative 2/1. Okay, or just -2. It's the same thing. And then if you had 4/3, the reciprocal, just flip it. This would be 3/4. Reciprocal of -8, this would just be -1/8.